You've probably heard the phrase time is the fourth dimension, but what does that actually mean? Is time just another dimension like length, width, or height? And how does this idea fit into our understanding of the universe? In this video, we'll break it all down and explain why scientists think of time as the fourth dimension, how it works in physics, and what it means for our everyday lives. To understand time as the fourth dimension, let's first talk about dimensions. A dimension is a direction in which you can move or measure something. A one-dimensional object, like a line, only has one dimension length. A two-dimensional object, like a square, has two dimensions, length and width. A three-dimensional object, like a cube, has three dimensions, length, width, and height. The world we live in is three-dimensional because we can move through these three directions. But time is often called the fourth dimension because it adds something new, the ability to move or measure events in the past, present, and future. Thinking of time as a dimension became essential after Einstein introduced his theory of relativity in the early 20th century. Einstein showed that space and time are interconnected, forming what we now call spacetime. Instead of treating time as something separate, relativity combines it with the three spatial dimensions into a single four-dimensional fabric. Here's where it gets interesting. In spacetime, time doesn't flow in the way we feel it. Instead, it's more like a coordinate, similar to how you'd describe a location in the three-dimensional world. Imagine plotting a point on a map with latitude, longitude, and altitude. Spacetime adds a fourth coordinate, time. Einstein also showed that time isn't constant. It stretches and compresses depending on how fast you're moving or how close you are to a massive object. This is called time dilation. For example, astronauts on the International Space Station age slightly slower than people on Earth because they're moving fast in orbit. So how does time function as a fourth dimension? In a three-dimensional world, you can describe an object with three coordinates, its position in space. But to fully describe an event, you need to add when it happens. That's where time comes in. It's the fourth coordinate that completes the picture. For example, think of a train arriving at a station. To meet it, you need to know not only the station's location in three-dimensional space, but also what time the train will arrive. Without time, the information is incomplete. But here's where it gets weird. In Einstein's spacetime, all moments, past, present, and future, exist simultaneously like a block. This idea is called the block universe theory. From this perspective, time isn't something that flows, it's a dimension we move through, just like we move through space. Even though time is considered a dimension, it's very different from the three spatial dimensions. Why? Because we can only move forward in time, while we can move freely in space. This forward-only motion is tied to something called the arrow of time, which is driven by the second law of thermodynamics. This law states that entropy, or disorder, always increases over time. That's why we remember the past, but not the future, and why broken eggs don't spontaneously reassemble themselves. So while time is a dimension in space-time, it behaves very differently from space. It's directional, irreversible, and deeply connected to the physical laws of the universe. In summary, time is called the fourth dimension because it's an essential part of how we describe events in the universe. Einstein's theory of relativity showed us that time and space are part of the same fabric, bending and stretching based on gravity and motion. But unlike space, time has a unique direction, tied to the laws of physics and the universe's structure. So, the next time you hear someone say time is the fourth dimension, you'll know it's not just a metaphor, it's a scientific fact that shapes reality itself. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating science content. And put your comment below about the fourth dimension. Thanks for watching.